Alright class, so today we are going to be working with radicals, and I mentioned yesterday that this could be something that you've covered in Algebra 1 before. It should be, but if you haven't, that's okay. We're going to start with the basics. So before we even get started, you do need to know your perfect squares. So what we're going to do over here is we're going to write in our margin. Actually, let's go along the top. So, well, I don't know. I haven't decided. Let's go along the margin. So 1 squared equals 1, 2 squared equals 4, 3 squared equals 9, and just keep going. 4 squared equals 16, 5 squared equals 25, 6 squared equals 36, 7 squared equals 49, 8 squared equals 64, 9 squared equals 81, 10 squared equals 100, 11 squared is 121, 12 squared is 144, and 13 squared is 169. Okay, so why did we list all these things? All these things called the perfect squares. Well, if you have your perfect squares memorized, then simplifying radicals becomes a lot easier. So all of these are called your perfect squares. And I did them in highlighter so that they stick out, but the rest of my problems I'm just going to do with pencil. So to simplify a perfect square is easy. You guys have probably done this before. So an example is the square root of 25. Well, whenever you're finding a square root, you just ask yourself, what number times itself gives me 25? That's the square root. So it's 5. The square root of 64 is 8. And the square root of 169 is 13. But what happens when we have ones that aren't even like that? So non-perfect radicals. How do we do those? Well, let's see. Let's first of all just go with an example of a non-perfect square. One that I like to use is the square root of 63. So if you think about it for a second, you know that it's somewhere in between 7 and 8, really close to 8, okay, if you were going to do a decimal. But we don't want a decimal. We want our answer to be exact, okay, so it's going to be expressed as an exact irrational number. Irrational means it goes on and on forever. So we have to talk about what goes into 63. What divides 63? So this is the part where you might need a calculator. So pause the video, make sure everyone has a calculator. But you want to look at what's the biggest perfect square that divides 63. So if you go through this list, 1 divides them all. But 9 will be the biggest one. So rewrite the square root of 63 as 9, the square root of 9 times 7. Those two things are equal. And now we can take the square root of 9 and bring it out front. Square root of 9 is 3. So now the 9's gone and all that's left under the square root is 7. So the square root of 63 equals 3 square roots of 7. Let's try another one. Say we have the square root of 72. So we need to go through and figure out the biggest perfect square that divides 72. So 4 divides it, 9 divides it, 16 doesn't, 25 doesn't, 36 does. I'm doing the work for you, but that's the way you think through it. So 36 is the biggest perfect square that divides 72. So we're going to rewrite it as the square root of 36 times 2. Notice these two are equal. Now we just take the square root of 36 and write it down out front. 36 is gone now, so all we have left behind is the square root of 2. Alright, now I want you guys to try one in your groups. Try to do the square root of 27. Pause this video and then restart it to see what the answer is. So the biggest perfect square that divides 27 is 9. Hopefully that's what you got. So you rewrite this as the square root of 9 times 3. Take the square root of 9, bring it out front. What's left behind? Just a 3. So 3 square roots of 3. So now that you've got an idea of how to simplify all non-perfect radicals, I'm going to throw in something else. What if we have the square root of a negative number? So write negatives under the radical. What about that? What are we going to do there? So let's see. Say we have the square root of negative 25. Well, you've always learned that you can't have a negative under the radical, but you can, okay? Here's why. We learned before, put this in a thought bubble over here, that I equals the square root of negative 1. So what if we broke this apart into negative 1 times 25? And then we can do the square root of 25, that's 5. So now we have 5 times the square root of negative 1, or 5i. Voila! So we just took a square root of a negative number. Let's try it again. Square root of negative, 16. That's going to be the square root of 16 times negative 1. Do the square root of 16, that's 4, times the square root of negative 1, which is 4i. Let's try it one more time, this time with a non-perfect square. Let's do the square root of negative 24. Try to do this on your own with your group, pause the video, and then start it again to find the answer. So what we're going to do here is look for the biggest perfect square that divides 24. So as we go up here, 4 divides it, 9 does not, 16 does not, and once we get bigger than it, none of those are going to divide it. So 4 is the biggest perfect square. So we're going to write this as 4 times 6 times negative 1. Okay, so there's our 24 and there's our negative 1. So we're going to take the square root of 4, bring it out front, so we have 2 square root of 6 times negative 1. Now here's the weird thing. Whenever we have a square root of negative 1, we're going to pop an I out, okay? We're going to pop the I out next to the 2, and we have 2i square root 6. The negative 1 goes away. So right here, I want you to write that. Pop the I out. So anytime you have a negative under the radical, just pop the I out, because I is equal to the square root of negative 1. All right, so now I'm going to leave you guys with some more practice problems. I do want you to leave some room over here because we're going to be adding and subtracting some radicals tomorrow. So over here, let's go ahead and let's actually do it this way. Let's divide this into 4 equal parts for tomorrow. We're going to call this top part add radicals. Subtract radicals. Down here, what do you think we're going to do? Multiply radicals, divide radicals. So I'm going to grab a highlighter just to make it cutesy. We're going to add, we're going to subtract, we're going to multiply, and we're going to divide. And that's what we'll be learning tomorrow. But for today, I just want you guys to focus on these. Being able to do non-perfect squares and negatives under the radical. So go ahead and get out your warm-up sheet. And that's where we're going to do some of these practice problems. So Here are some that I want you to give a try. And I want you to do these in your group, and then we'll go over them tomorrow whenever I get back. The first one is the square root of 96. Notice that one doesn't have a negative. I also want you to try the square root of negative 45. I also want you to do the square root of negative 48. And last one, I want you to do the square root of negative 42. Okay, so give those 4 a try, talk about them in your groups, and tomorrow we'll go over them in class. Good luck!